with your Inventor application open, first you want to go to File, and we want to create a new assembly. Okay, then we want to select under the Assemble tab, Place, and we want to place our two parts that we're going to mate. So we will select our two parts and hit Open, and then we'll zoom back out and you can see the two parts here. So we can just place them any place by clicking, and then we will right click and hit OK to exit the command. Okay, now that we have our two parts placed, we need to start mating them together so they're constrained properly to each other. So first we go to the Assemble tab, and under here we have this constrain command. Okay, so this is where we're going to do our constraints to mate these parts. So we'll hit the constrain to open the dialog box. We're going to leave this as this mate type, as this would work for what we need. So first I'm going to select the hole. Now I make sure that I have this arrow with this center line, because if I select this, I'm selecting a center point or an edge. See, center point or center point here, which is not what we want. We want this, which is the center line. So I'll click first the hole in the plate, and then I'll click the hole in the shaft, and I'm selecting axis. So those two parts are now mated concentrically between those two holes, and I'll hit apply and cancel this, so you can see it's not moving. They're moving together based on that hole. Now we have to further constrain it, so we need to mate these other two holes. So we're going to hit constrain again, and first we're going to select our hole in the plate, and then our hole in the shaft, hit apply, and now those two parts are mated between both holes to keep the plate from rotating separate from the shaft. Now, as you can see, we still have one more mate that we need to do. We need to mate this surface to the surface on the shaft. So again, we're going to open the constraint. We're going to leave it this same selection for the mate type. We're going to select this back surface of the plate, and we're going to select this flat surface on the shaft. And now these two are going to be mated coincident to those two surfaces. So we hit apply, and now you can see the two pieces are moving as one. But here's the next step. These pieces should not be moving, so we need to further constrain the assembly. So that'll show that in the next step. Now that we have our two parts mated together, now we need to further constrain them so that they don't move around like we see. We need to fully constrain the assembly. So we're going to do this by using planes. So I'm going to expand the origin out so I can see my main planes, YZ, XZ, and XY. And I'm going to take and expand out the shaft. Okay, and I'm going to expand out the planes on the shaft, which have the same corresponding YZ, XZ, and XY. So first I'm going to hit constrain. I'm going to keep this as this type of mate. I'll first select the YZ plane of the assembly drawing, and I'm going to select the YZ plane of the shaft. As you can see, it reversed it, but we can fix that by flipping it. So now we're back in the same orientation. That's just by this mate flip back and forth, as you can see. Now we're going to hit apply to mate those two parts together. those two planes together, excuse me. Now next, we need to continue on with the XZ plane. So first we'll select the XZ plane of the assembly, and then in the tree we'll select the XZ plane of the shaft. And we'll hit apply. I'll hit cancel so you can see I'm moving my cursor all around, and now I only have one axis plane that I'm able to move on, but still not fully constrained, so we need to finalize that constraint. So I'm going to hit constrain, and I'm going to do the last plane here, the XY plane, and then the XY plane of the shaft to mate those two together. Hit apply, or before I do that, I could flip. You can see the part moves slightly, but I'm going to hit apply, accept. Not sure why that threw a fit, but it's probably because I was messing around with the orientation of the planes. So I'm going to go back, we're going to delete this plane, we're going to start over. We're going to constrain XY plane of the assembly to the XY plane of the shaft and apply. And it still doesn't like it. Cancel, edit. Ah, I just found out. And here we go. It was the wrong orientation. It was trying to force it in this orientation. I had to make it flush instead. Now that it's accepted it, now I'm good. So a little on-the-fly diagnosis. So we ran into some trouble. I was able to fix it. And as you can see, I can't move this part any further because it's fully constrained to each other with these three mates, and then also with the main planes of the assembly. So now we have a fully constrained part, and we can save this part. I'm going to save it. I'm going to save it as my shaft and plate assembly. And there we go. And here, I'll bring this over, and we hit OK. And now we have this assembly all done, saved, fully constrained. Okay, now that we have our part fully constrained and assembled with all of our new mates, what we're going to do is under this Inspect tab, we're going to do and run this Analyze Interference command. And this will check for interferences, if there are any, between the two parts. So we're going to hit define set 1. So we're going to select the shaft. And number 2, we're going to select the plate. Now we're going to hit OK, and it's going to run a quick check. And here it says there are no interferences detected. So my assumption is that everything is good, and we can save our part, our assembly, and then we're set to go. Okay, now to do a quick recap. As far as the constrain goes, when we open the dialog box, we have multiple types of ways to constrain and mate parts. There's a symmetry part mate, there's this insert, tangent, an angle between the two surfaces, and this more of a universal type mate. So this one is good for making holes concentric to each other, axes concentric, points concentric, and then surfaces coincident. So it's one of the main types of mates that you will use in many assemblies, but obviously these others are equally as important. But in this case, this is the one what we needed for this particular assembly. There's also motion mates, rotational, transitional between two, I assume, tangent points. And then I don't know this constraint set, but we will get to that later, I assume. UCS to UCS. Okay, so that's the XYZ to XYZ. So you're doing the origin. Technically, you're aligning the X, Y, and Z planes when you insert parts together to get them oriented all the same direction. Thank you for watching.